Hello, pre-calc honor students. Here we are at 12.8, Applications of Determinants. And we're going to use these to solve algebraic and geometric problems. First, the idea of Cramer's rule. It can be used to solve n equations and n unknowns. Now, a few terms we have to define first. Here's an example of a system of two linear equations and two unknowns. And we have the old techniques to solve this, but this new one is kind of interesting because it's expanded to any number of equations and the same number of unknowns. D is the determinant of the coefficients on x and y, so this can be 3, 5, 4, 9. And dx and dy are done by replacing those coefficients with the constant terms you have over here. Let me show you here. D is the determinant of the leading coefficients on x and y. So that's 3, 5, 4, 9. So we get 27 minus 20, or 7. D sub x looks just the same as D, except you come along and you erase your x column and replace it with 7 and 11, because that's the constant column. So that's D sub x, and from that we get 7 times 9 is 63 minus 55. I believe we get something like 8. D sub y, again, start with your 3, 5, 4, 9, your D matrix, but then come along, this time erase the y column, and replace it with 7 and 11, and we get 33 minus 28, which is 5. Now, you can check this. D sub x is 8 and D is 7. So there's your answer for x. And y is defined as D sub y over D, so that's 5 sevenths. 8 sevenths, 5 sevenths. And that's the solution. Now, let's see how this works on a bigger system now. Solve this system of equations. So we're going to need a lot of matrices here. First of all, you got your D, and that's 3, negative 1, 2, 2, 3, negative 1, 7, negative 4, 3. And I'm going to let you do this one on your calculator, okay? And here's a little calculator tip you can do. TI-89 tip. We can actually enter this as a matrix because it's a lot to enter on the home screen. So I'm going to show you where that is on your calculator. Let me whip up the calculator here. Matrix is under the apps. So you're going to have to look up your apps. It's in the apps menu. So get out the calculator, go to the apps menu, and go to where it says Data Matrix Editor. Make a new one. And we want this to be not a data but a matrix. So that's one of the first options under Type. So under the Matrix Editor, you want to look up under Type. You want to go to option 2, which is Matrix. And then you can name it anything you like. I just usually like to call it MMM. Come up with something quick. And here's where you put in the row and the column dimensions. We're looking at a 3 by 3 matrix here each time. So 3, 3. And you can enter in the matrix then. You should have a little array where you can go back and put those in. Let's do that. Okay, now you go back to your home screen and just type in DET, MMM, or whatever you use to save your, that's where I save my matrix in MMM. and I get an answer of negative 30. Now, it's easy enough to edit this, so you got negative 30 for D. To find D sub x, which you recall was taking this. Let's set up our D sub x menu. D sub x, we replace the x column here and leave the other two columns alone. In D sub y, you're going to replace the y column, so leave the other two columns alone. And D sub z, replace the z column, so leave the first two columns alone. And so then each time you're filling in the 4 into 14 negative 4, oopsie, that's the wrong color. Four, 14, negative 4, 4, 14, negative 4, 4, 14, negative 4. And now these should be easy enough to put in the calculator because you can go to the matrix editor and just change that column and then find out all these new values. Okay, let's look these up before we go on to our next step. On the calculator, go. Okay, and oddly enough, you get negative 30 for D sub x as well. I just realized something that, it can save you a lot of time. You're on the home screen now. To quickly get back to apps, you can hit the thing above the apps, where it switches you, toggles you back and forth between menus. Let me show you on the what I'm talking about here on the calculator. Right above the apps, there's this thing. So if you use second, and it's like a screen switch thing, it'll take you quickly back to what you were working on before. That way you can go quickly from your editing your matrix to your home screen. Hope that helps. Let's go back to see what we have here. Oh, we were in the middle of it. I had pinned that page down. We're in the middle of this example. Okay, let's continue and get these in. Sorry, this got transcribed wrong. That is an actual positive 3 there. Okay, continue. And I get negative 150 for D sub y. Now make sure you're not just changing this column, but remember if you change MMM, you got to reset those things again. And let's get our D sub z. And we end up with negative 90 for D sub z. So, oopsie. Now we finish up by going like this, coming up with all our x, y, and z's. X is D sub x over D, so negative 30 over negative 30 is 1. Y is D sub y over D, so that's negative 150 over negative 30, so y is 5. Z is D sub z over D, negative 90 over negative 30, and we get 3. So there's our solution. 1, 5, 3. And if you think about it, that's a point in 3 space, and what we did was intersect 3 planes. Each of these is the plane. All right, I want you to be aware of the other applications too. Here's the geometry applications. In 2D, we can find the areas of a parallelogram from the vectors of 2 adjacent sides. So, if I have this vector, let's call it U, vector U, and this is vector V, and we're in 2 dimensions, and so let's say U has coordinates A comma B, and V is C comma D. Then we get the area just as the absolute value of the determinant of this matrix of the 2 vectors A, B, C, D. So it becomes the absolute value of AD minus BC. That works out very handy. In 3 dimensions, It's a little trickier. Let's say we've got three vectors here, and we call this ABC, and this is DEF, and this is GHI. Then again, we can find the volume with the absolute value of this. And I had to tack that in because a lot of times kids just put that down. If you get a negative answer, it has a certain indication, but then you take the absolute value to get the positive answer of ABC, DEF, GHI. So you can use the determinant of the 3x3 matrix of the three vectors coming from the corner to come up with the volume of that parallel pipette. Now, example 3, find the area of a triangle with vertices at 1, 2, 3, 6, and 6, 1. So we had approaches before that might involve coming up with three sides in Heron's formula, or coming up with this angle from the law of cosines and using 1/2 AB sine theta. But we've got a much swifter trick here. PQ, vector PQ, is going to be 3, 6, minus 1, 2. 2, negative 4. 2, positive 4. 2, positive 4. I was able to check my mistake there because I have a picture. 2, positive 4. So that's this vector here. We're going over 2 and up 4. Vector PR is going to be 6, 1, minus 1, 2, and that's 5, negative 1. Sure enough, over 5 and down 1. So when we put these 2, 4, and 5, negative 1 into a determinant, we get negative 2 minus 20, negative 22. The absolute value of negative 22 equals 22, and that equals the area of the parallelogram. Parallelogram. So what we found was all this. But as you can see, we only want the triangle. So the triangle is like this, and it's only half the area of that parallelogram. Half of 22. And so we get 11 for our final answer. Okay? Flange out.